In this first item on the second exam for spring 2016, we have a stress block associated with plane stress that's been provided to us, and we're asked to find the principal and maximum shear stresses and to draw and label these on properly oriented stress blocks. Although we could do this with the stress transformation equations, it's actually quite a bit easier to do this with Mohrs circle. So with Mohrs circle, then we want to plot two different points that are orthogonal to each other. Let's call these points A and B. Point A will have the coordinates of 50 ksi in tension for a normal stress and 40 ksi, and that would be counterclockwise. So when we come along here, let's mark this out as a 1/4 inch per 10, so that would put us out to here. There'd be the beginnings of A, that'd be 50, and then counterclockwise would go down, so we'll go down 40 units or 1 inch. There's your 40, and there's your point A. And then point B is going to have 10 units in compression and 40 units in clockwise. So we'll come out here at 10, and then we'll go up 40, and there's point B. That will form our diameter of Mohrs circle, where it is at the center of -10 and 50, which would put us right at then 30 difference. So there's your 20. So that's going to give us a interesting cutesy pie situation here. We got 30 there, 40 there. That means with our hypotenuse, a right triangle from our, that will have that radius of the 50. That's your cutesy pie thing for the day. So that will come out, bam, here's the max there, 50 on the horizontal will put us out here, that's at 70, and likewise, bam, over here, that put us at 30 for compression, and let's get the bam 50 here, and that will give us our max shear stress, two different locations, and will give us then our two different principal stresses. So there's going to be our values for everything now. We just got to get these in properly oriented stress blocks. Right? So let's go find out what those are. From point A, if we go then counterclockwise, we'll get to our first principal stress. So 2 theta P1 will equal arc tan of opposite over adjacent, so 4/3, and that would be 53.1 degrees about. So theta P1 would equal 26.5 and change for that first one. Right? So if we started off with an angle, or sorry, a stress block that looked like this, then when we go and rotate at about 26.5, then we're going to get our new stress block. Like so. There's your 26.5 degrees. And if we started here at A, that's right here, if that's your point A, when we rotate that, then we're going to get to here where we have a 70 ksi normal stress in tension, and then at 90 degrees to that we'll have the other one. There's 30 degrees, sorry, not 30 degrees, but 30 ksi compression. and 0 shear stress for those. I suppose you probably want me to draw in more circle too. It would look something on the order of looking more like Mohrs oval than Mohrs circle, but you get the idea. So that's one of the stress blocks, and then so there's your principles. And then if we go the other direction, then we'll get to the max shear stress out here. Notice that the sum of these two is going to be 90 degrees, so that means 2 theta S is going to be equal to 90 minus the 53.1 degrees, or that theta S will equal 18. I think it's 43 degrees or so. So when we go the other way, there's ultimately a 45-degree angle between the two frames of references that I'm drawing here. And I'm going to pull that out just a little bit further to make it easier to draw everything. And now we have to make sure we're going in the right places at the right time. From A, we're going to go 18.43. So from A over to this one, we end up with a net of 20 KSI in tension. It's going to be true in all of these here, but this is the one that we just found. That's this point right there. Call it A prime for the heck of it. And so note that's counterclockwise stress on that one. So that's down to our 50 right there. There's our 20, 20, 20, 20. And so we've got the rest of our shear stresses like that.